All right, so let's get started. Welcome back, everybody. Um, today our topic is Quicksort. I'm hoping that I'll get some questions today because I hope that as usual the lesson is fairly self-explanatory. Quicksort is a fun sorting algorithm to think about. It's got kind of a neat combination of things. It's got like a really sort of interesting bit of imperative code, this partitioning function that you guys get to write today. And then it has also this really fascinating sort of recursive process, right? So, one way to think about it, or one way I like to think about it, when you compare it to merge sort, right? So merge sort, it's like it takes apart the array first, and then it puts it back together in a sorted way, right? So you can imagine if I gave you an array, you're like breaking it in half, breaking the halves in halves, breaking the halves in halves, and you keep doing this until you get down to just like one individual element. And then, we take all these elements and we start putting them back together. And as we're doing that, because we're applying this merge function, that is, because we start with things that are sorted, which are size 1, we put them back together in a sorted way using this merge method. That allows us to build up a larger and larger sorted array until we've sorted the entire thing. So on some level, it's like merge sort disassembles the array as the recursive calls work downward to the base case. And then it's doing the sorting on the way up when you're actually applying the merge. Quicksort works on the way down. Quicksort really doesn't ever need to return up because as it's going down, one way to think about it is the way that Quicksort decides what the smaller subproblems are is by running partition, right? That's we looked today on one of the examples on how to implement Quicksort once you have partition, which turns out to be appealingly straightforward. And the idea is that Quicksort uses partition to make the problem smaller. That partition is also what's eventually solving the problem, because it's almost like I take a big unsorted array, and the partition process is saying, okay, well, how do I make the problem smaller? I'll divide it into 2 smaller unsorted arrays. But critically, those unsorted arrays I can approach independently. I don't have to solve them together, right? So I took this one big interconnected problem where I had like n values, and they could go anywhere, right? I mean, it's possible that the smallest value is at the very end. It's possible that the biggest value is at the front, right? So stuff, when we actually rearrange the array to sort it, stuff could be flying around all over the place. And the partitioning step is like bringing some order to this. So it's saying, okay, well, again, I'm going to just choose this one value. I'll pivot everything around it. And when I'm done, I do have smaller problems to solve. And sometimes now, what we pointed out is because, merge sort is always going to divide the array in half. Because Quicksort is doing this partition step, it's not guaranteed that the 2 arrays that you're left with are actually roughly the same size. And the pathological cases for Quicksort that we explore in today's lesson occur when you have cases where the arrays that are, the partitioning process does not divide the array very effectively. So in the worst case, the partitioning process ends up only making the problem 1 unit smaller. So if I pick the wrong value for the pivot, it's possible that rather than getting, 1 array, 2 arrays of size, n over 2, I basically end up with another array of size n. It's like n minus 1, but it's close enough. And so, and again, you might be wondering, I think one of the natural confusions here is like, why does that matter, right? I still have to do the same amount of work, right? But it's the number of times that, so every time I run partition at any level of this problem, it's going to be O(n). So it drives the performance of Quicksort, and also merge sort is the number of levels. So both merge and partition are O(n). So the building blocks for merge sort and Quicksort have the same complexity, computational complexity. It's really just how many times I have to apply them, right? Because merge sort's breaking the array apart, And the number of times it has to do that is a function of how many times it takes us to get down to an array of size 1. So if I give you an array of size n, and you break it in half every time, it takes you log base 2 of n steps to get down to 1. So that's where that log n comes from in the n log n runtime for merge sort. N is the merge at any level, log n is the number of levels. So in Quicksort, if I get good pivot value, so if the pivot value that I choose at every step roughly evenly divides the array, then I end up with a merge sort like runtime because, again, the partitioning step is on. The number of levels at that point is the same as merge sort because at each time I'm dividing the array in half. But because I'm running this partition step, I'm not guaranteed to get an even split. I might end up with, like I just said, an array of size n minus 1. And if the pivot value doesn't divide the array evenly, what can happen is that the number of levels starts to increase. So when we have this walkthrough here where we kind of look at the performance of Quicksort just by counting the number of, counting the amount of partitioning that we have to do. And what you see is that even for a random array, it bounces around. I wish we could have done this with merge sort. Maybe we will when we review arrays after break. We'll do a similar performance comparison using merge sort and count the number of the amount of merging we have to do. But what you'll see with merge sort is that it's identical. Like merge sort, there is no part of merge sort that cares what the data is. Whereas when you write, now when we do the pivot, right, it's the result from the pivot. Sorry, I keep saying, I get pivot and partition confused. It's the result from the partition that causes the issue here. The partition step itself has no data dependency, right? It's sort of like merge, right? It's going to crank through. You guys are working on it right now. When you're done, and we'll look at it together after break, look at that code and tell yourself, okay, do I see any places where this might break out or whatever? And the answer is no, right? I've got to examine every element in the array, compare it against the pivot value, and do the swaps appropriately. Same thing with merge. Got these two smaller arrays, merging them together. I gotta, crank all the way through that larger array from the beginning to the end. So those loops are not going to terminate. They don't care what's in the arrays. Where the data dependence comes in with Quicksort is where the pivot ends up, right? If the pivot ends up in the middle, we're golden, right? If the pivot ends up really close to one side of the array, then we're in trouble because the number of levels is going to start to go up and the complexity of the problem is going to start to go up. This also gets really tricky, right? Because there's no guarantee. So merge sort is like so predictable, right? I mean, you could just do a graph showing exactly, how many steps it takes merge sort because right, ahead of time. There's no question about it. With Quicksort, you might have like the first half of the array that partitions very nicely into even pieces and the second half of the array that's a mess. Right, so it can just depend. It depends so much on the data that's in the array. And again, that's why when we were doing those experiments today in the lesson, you see that the numbers bounce around all over the place, right? Because it's like sometimes you get a good partition in one spot and a bad partition in another. Sometimes you get good partitions all the way through. It really depends. So now you might wonder, and I'm sure that at some point you'll be quizzed on stuff like this, right? Why use Quicksort at all? Given that compared to merge sort, it feels like it needs a lot more space. Sorry. Compared to merge sort, Quicksort seems more unpredictable. It's like sometimes you get O log and log n, but that's kind of the best that Quicksort can do. Whereas I might have data that I feed into it that causes it to go O(n) squared. And so why use Quicksort in the first place? And the reasoning is that Quicksort uses a lot less space. And so again, when you look at that partition method that you're writing today, compare it with merge that we did yesterday. And again, we'll do this together once the homework's done and we can look at the partitioning code together. The partition and merge have very different amounts of extra space that they need. Merge has to literally allocate an entire new array, whereas what's cool about partition is that it works only within the array that it's given. It needs a little bit of extra space for that pivot, like that temporary value that it's using, but that's it. Whereas with merge, I need an entire second array. And so it's the space complexity which is the advantage of merge sort. And while we think a lot more about time complexity in terms of runtime than we do about space complexity when we talk about computational complexity in this class, space is a real thing, right? I mean, particularly when you have massive data sets, right? So if you're Google and it's like, I've got a petabyte of data, and in order to, it's hard enough to store that data, right? To find enough computers with enough storage to just store it. And now you're telling me you need as much space to sort it. It's like, now it's starting to become a harder sell. So reducing the space usage of sorting algorithms is also really important. Okay, so that's all I have to say about Quicksort. It's funny, like when I started teaching this class, I remember I'd get a big thrill when I could get a Quicksort partition right. I would practice, right? Like these are algorithms. I just want to, point this out in case people are thinking like, oh man, today's homework is hard. This is not something I could necessarily do if I was, if you put a gun in my head, it was like, oh, implement partition. It's like, oh, I think I can. I've done it so many times now. But there's always a little thrill to getting it right. Quicksort as an algorithm, I think, has this sort of magic to it, right? In the sense that, merge sort, it's sort of like, I sort of get it, right? I can sort of understand why merge sort works on a conceptual level, whereas Quicksort, there's something sort of mysterious about it even when it does work. So it's kind of fun to think about why it works and how it's actually approaching the problem. Okay, questions. As usual, stick around. I'll answer anything that's on your mind. Stuff about Quicksort, stuff about sorting in general, stuff about life, the MP, whatever's going on. I'll stick around today until the top of the hour, maybe a little bit earlier. It depends on if anybody's around and is curious about anything. So fire away. I am at your disposal. Good question. I would recommend today's partitioner. That's really an iterative solution. Like every algorithm, I'm sure there's a recursive approach. I wouldn't. Yeah. Not even sure. I'm not even sure if I can. That's a really fascinating question. I'll think about it. The way I know how to do it is through an iterative approach, and that's what I would suggest. It's kind of weird, right? Like how I'm trying to think about how you make. Yeah, I'm trying to think about how you would approach that recursively. So, an array of size 1 is already partitioned, right? An array of size 2 is also, well, you have to sort it. Well, actually, an array of size 2, I guess you could pick either value to be the partition depending on which one is bigger. Yeah, no, I'll think about this more. I can't, off the top of my head, come up with a good way to do that recursively, but I'm sure it exists. say what you want about me, but I'm not someone who naturally approaches problems recursively. I've learned over time kind of which problems to think about recursively. And so now I'm not afraid to use recursion where I feel like it fits my mental model, but it's not the first tool that I reach for when I'm trying to solve a problem, right? Usually I'll think, okay, can I solve this in some iterative fashion? But yeah, so again, when anything, but I'll just think about this until I get another question. I mean, so again, with any recursive problem, the question is like, how do you kind of, I think the question would be, if I have something that's already partitioned, right, and I want to add, well, actually, now that I think about it, no. So this is cool. I think you can do this recursively. So this is coming to me. All right. So here's the approach. You have to break it down to have a base case, which is an array of size 1, right? That's your pivot value. That's the trick. Past that point, right? So how do I merge it with another array? So now you think about, how do I add values to this? And the way you do it is, if the value is greater than the pivot, you put it at the end. If it's less, you put it at the beginning. There you go. So in that way, you can very, very easily build up your... Now, I guess like one interesting thing here would be somehow as you perform the recursion at each step, you kind of need to know what the pivot value is. And so that might be a little tricky, right? Because I need to know kind of like, but I suspect you could do that. Or I guess what you could do is you could have the pivot value stay, I'm trying to think, if you had it stay in the middle, then could you figure out where to put it at the end efficiently? Yeah, I think that's the trick though. I mean, so in general, if you give me an array and I know what the pivot value is, and I know, and then you say, add this new value, it's very, very trivial to do this, right? In ON, in constant time, right? You need this to be constant time because your recursion is going to create the ON step. So I think what you do is you say, okay, if the pivot value is, if the pivot, if the value is, like I said, if the value is less than the pivot value, I put it at the beginning of the array. If the value is greater than the pivot value, I put it at the end of the array. I need to do a little bit of work here to kind of like figure out how to deal with arrays in this situation, because it's just going to be a little bit awkward, right? Because I'm going to kind of have it. Well, actually, yeah. Anyway, I think there's a way to do this, and it would probably be a fun problem to mess around with. The other way you could do this, because you kind of don't want to have to keep creating new arrays. That's going to be really inefficient. So the other way you could do this is you could pick a value in the middle of the array as the pivot. Remember, the choice of pivot is totally arbitrary. And even if you wanted to pick the first value, you can always swap it with the value in the middle, right? So at some point we may ask you to pivot around the last value in the array. And the way to do that, honestly, is to first swap it with the first value and then run your same pivot algorithm that you just implemented today, right? That works on the first value. So any pivoting algorithm, sorry, I keep saying pivoting, any partitioning algorithm can be very easily modified to go along with, first item is the pivot by just moving the item you want to use as the pivot into the first position. It doesn't matter. It doesn't change the values that are in the array if you just swap it with some other value. So imagine I pick a value in the middle of the array, right? And so when we do recursion on arrays, when we're working in place, what we'll do, we did this when we finished Quicksort today, is we introduce bounds, so we kind of know what part of the array we're thinking about. And so I think what you would do is you'd basically like start with one value in the middle of the array, and then grow the bounds kind of incrementally in both directions, right? And as the array gets bigger and bigger, at any given step, you're considering one new value and you're figuring out how to adjust the array to accommodate for that. I think doing that would work. And it would be kind of cool. So yeah, give it a try. I mean, another thing you could do is you could certainly implement this in the way that we kind of talked about at the beginning, where you put things at the beginning or the end, and just do the array copies, right? I mean, the whole point is to just have some fun with recursion here and see if you can get this to work. But I think there are some pretty viable recursive solutions here. The difference with a recursive solution is that you're gonna make the array bigger. So again, your base case is a single value because that is now the pivot value. And then at any given step, you're adding a new value to the array. And the trick is to figure out how to do that in constant time, right? You can never, your recursive step cannot involve any type of looping, obviously, because if it were, it wouldn't be recursion. And so you can't, because that'll also make it on, right? And you're going to have n of those steps, and partition needs to be on. And so you need to find a way to make to take the smallest problem that we identified, which is an array with a single item, and then make it bigger by one value at a time in a way that's constant time but still preserves the pivot. And I think there is a way to do this. And again, I just would have to think about it a little bit more. But yeah, fun. Well, actually, hold on a sec. Yeah. Anyway, it's definitely doable. It'd be kind of fun to figure out how to get it to work. Other questions? That's a good one. I'll be thinking about that for a little bit more today. Oh, yeah. So the question is about the syllabus. The syllabus says 70% marks mean, so that's basically like a bet. This is the language that we use because of this assessment that we go through, right? But think about it. The idea is that if you get a C in the class, you're supposed to have learned the core learning objectives. Is that true? I don't know. I'm not sure I believe it's true. When students get a C in this class and then try to proceed onward to a course like, CS 126 or the new CS 128, typically the CS advisors will step in and say, whoa, you should really retake CS 125 and do a bit better. I think for courses like this class, where on some level, again, I think I've told this story in the past, but I'll never one of the things that's always struck me about Intro CS, and I've never forgot this, is going into my Intro CS course the first day of class at Harvard. It was not being taught by David Malin, then it was being taught by our faculty member named Stuart Schieber, who was a pretty decent guy, and he did a great job teaching the class. It was not the sort of phenomena that CS50 became after David took it over, but anyway, it was still quite a good class. But anyway, on the first day of class, he said something that I've never forgotten, which he said, "This is one of the only classes at Harvard that teaches a skill. The other ones are like foreign language classes, right? I think for a skill-based course, I don't even know what this means in any class, right? Like I learned 70% of the material. Well, it's like I'm not teaching. There's no 30% of the material that I'm teaching that I think is unimportant. Maybe it's like the week we do after break, but that's really just to give you guys some space to kind of continue to practice with the stuff that we've already done. So, is there 30% of the material in this class that you could throw overboard and do okay down the line? I don't think so. It's like when you go in and take a driver's education test, right? It's like if you only run like 30% of the stop signs, they're not going to give you a license, right? Like, gotta do a bit better than that, If it's like, oh, right, I was in my lane 70% of the time, yeah, right. I used my turn signal 70% of the time, right? It's not really good enough. This is stuff that you have to know. So anyway, but that language is there because of ABET. You know, the idea is that if you get a C, you pass the class, and you're supposed to have learned something. And I think people who do typically do learn something, but they've also typically kind of missed out on one of the primary learning objectives for the class, given that particularly for the grading for CS 125 is very heavily weighted towards work ethic, right? I mean, this is a course where our approach to grading is heavily tilted towards you doing the work on a day-by-day basis, rather than showing up at some exam at the end of the semester that's worth 60% of your grade, and for 3 hours being able to regurgitate stuff that, you know, you've been up all night studying on Red Bull or whatever else, and then collapsing after the exam, at which point all of that information just immediately leaves your brain and you will never remember it again. And I know that for a fact because I did that. And there are many courses I took in college, some of which I even got passably good grades on, that I remember very little about. So anyway, that's also why I mean, I'm on a tangent, but that's fine. That's also why it sort of drives me nuts that we have this culture, it seems like, at Illinois where people are, you know, choosing courses based on their expected GPA in the class. I mean, that is just, in my opinion, one of the dumbest ways to approach college. You know, the course that I do remember something from and actually like made a really good friend in, and I feel like had at least some impact on my life, was a class that I did terribly in. Like I almost failed it. I think I got like a C or a C minus or something. And it was a course on American independent film. And it was hard. Like I am not a humanities person, and I didn't do very much of the reading, but I saw some movies in that class that were really fantastic. And like I said, I made a really good friend. And so anyway, all to say that, you know, we try to make sure that students that come through this class learn everything that they can, and don't choose classes by looking at the expected GPA. Like you're paying too much to go to college to approach your education in that way. It's just kind of silly. All right, mini rant over. What other questions do people have? Yeah, don't make any assumptions about your grade in this course. You don't know. You know, we haven't set the grading cutoffs yet, and we won't until the end of the semester. So I just wouldn't. You know, don't make any assumptions about your grade. Typically, I think people in this class are pretty pleased with their grade by the end of the semester. You know, if you're in the B range, I think it's up to you. I mean, I think that's a place where it's kind of more how prepared do you feel. Like, I think you have to at that point look at the. I think you have to look a little bit more at what you missed, right, and kind of why. Like, what was the problem, right? Is it like, I mean, if you get a B because, like, I don't know, I don't know. It really depends, right? I think, you know, I'd be happy to talk to people that are in that position and just sort of go over their grade in the class and say, okay, here's the parts that were problematic, and you know, here's where you could do better, and you know, how do you feel about this going forward? So I think that's a little bit more of a gray area. It says, if I missed a homework and receive the message, no, that message you will not lose credit is to encourage you to continue to experiment with the problem. That means that once you've earned credit on the homework, you can't then lose it by experimenting with the problem and getting a wrong answer, right? If you never earned the credit for the homework in the first place, then you have nothing to lose, right? But that message is there to reassure people who might want to go back to a homework problem and practice and, you know, trying to approach or whatever, which we totally encourage you to do. And I think next semester we'll probably have a better way to do that. Probably like one practice page where you can look up homework problems and use that to review for quizzes and things like that. Yeah, that's what that message is intended to convey. Good questions. Other questions? guys must be curious about something. What's going on? I'm also happy to just hang out. Yeah, sure. So the initial final project was going to be just having you extend the app that you've been working on, and there's lots of ways to do that. So there are new features that you could add. Some people might want to work on the UI, which is Android basic, right? Like it's what you get out of the box. It's not particularly pretty, or adding animations or whatever. Past that point, I mean, I think like we talked a little bit, and we certainly maybe we'll bring this up on the forum, kind of like as the semester is winding down, in case people want something to do over break. But at some point, I may get around to putting up a back end for the app, which you could then connect to, which would be kind of cool. That would remove that part of the code from your project, the server side code, but we could put that up somewhere, and then you guys could all share that. Make your app a little bit simpler, and it would be more of the kind of model that you would see in the wild, right? Where you don't normally have a server that runs inside your app, right? The server runs elsewhere, at some sort of shared location. I mean, it's supposed to be kind of a course browsing app, right? So what kind of stuff would you guys like to see? I mean, one thing is that right now it doesn't display ratings from multiple users. So I think there's one idea, which is create fairly obvious idea, which is allow it to retrieve the average rating from multiple users for a course and display that along with the user's own rating. You could display more information about the class. There's actually a lot more information that's in that JSON object that you guys are deserializing right now into a course. One of the reasons that you had to configure Jackson or I think we did this for you, but to ignore extra fields is that there's a lot more information in there. So you could display that information. You could try to parse that information so that you could pull out like the number of credit hours and things like that. You could, there's scheduling information there in terms of the times that various sections meet. So you could try to help people design like a schedule. I think some of these things exist in the tools that you guys have access to already on the website. I don't know. I don't get to use these. I don't get to register for classes. But I mean, so these, recreating these can be kind of a fun project. Dealing with date and time is a huge pain. It's doable though. There's the locations of classes, at least some of them, the ones that are being held in person. So that's actually a good question. I mean, you can determine, I've actually done this calculation because I was curious, which courses are online or in person. And so if you wanted to take all online classes, you could do that. So yeah, I mean, there's a bunch of different, features that you could add that involve utilizing more of the information in that, and sort of that's available in the JSON that we're already giving you, which is available just being pulled directly from the course catalog and presenting that to users in different ways. You might add in like social features, like if you want to take classes with groups of friends, being able to somehow like link your device to the device used by some of your friends, and get a sense of like what their schedules look like, and how they overlap with yours, and being able to choose some of the same courses or whatever. So yeah, I mean, I think there's lots of, I mean, I'm not a student anymore, to be honest, so I don't know where the opportunities are in this space in terms of like stuff that would be cool and new and attractive to students. I mean, I've heard people complain that they have to walk across campus, and if the locations of different classes, you could certainly warn people about long travel times between various locations and stuff like that. So So yeah, I mean, there was that sort of variety of things, right? And it was supposed to be kind of just another chunk of this, but in a more in a less structured way. And again, the idea, and I think we probably will reshift things a little bit next semester to be able to do this part of the course again. But on some level, that what we tried to do is design the MP to kind of represent what I would think of as a kind of a typical onboarding experience, compressed, but for someone who's going to go start working on an existing software project. So a lot of times, you have a lot of times when you start working. So the first thing is like, pretty much, I would say like the only things that start from scratch these days are almost side projects, right? I mean, not to say that nothing starts from scratch, but if you go to work for like a software development company, if you're working at a startup, then you're kind of starting from scratch. If you go work at a software development company, you're probably not starting from scratch, right? You're probably working on a big, well-established project. And there's this sort of process that people go through where frequently the first thing you'll be asked to do is to fix a bug, right? So like, let's say you go to work on, I had a former student of mine that went to work on Chrome, right? So he spent some time when he was in the onboarding process, just like triaging problems, right? And that's a great way to get comfortable with the code base. You're not expected to design anything new. You're just trying to get the old stuff to work properly, right? And of course, every project has these big databases of bugs that people have filed that they haven't been able to run down yet. And so, that can be a good experience doing a couple of those. Then, the next step might be to add something new, but something that's very derivative of the things that are already in the project. And that was kind of the bug triage was sort of the first MP checkpoint. MP1 was more of this, mimicking existing code, right? It allows you to understand the idioms that are being used by the code base. And I think for some people, it's also a sanity check to make sure that like you can write code that fits in with what they're doing. If your approach to like adding an extra route to a server is to rewrite the whole thing or try to, like people will be like, oh, okay, no, never mind. This is not how we work here, right? You may not like how things work. You may not, agree with the coding conventions or whatever, but they're paying you to not change everything all at once. And other people disagree with you. So that's kind of step 2. Step 3 is to do a bigger chunk, right? Which is sort of what we did with this checkpoint. And then the next thing would be to actually have a potential new developer propose something new, right? And that's more all-encompassing, right? That's not like you're owning this, right? So or that might happen naturally. You're not like your boss would point at you and be like, okay, you're going to do something new this week. It's like after working there for 6 months, a year, or whatever, you might get to the point where you feel comfortable going up to someone you work with and be like, hey, I think that we should really add this new feature or whatever. I think this would be a useful thing to do. And they might say, yeah, that sounds great. Why don't you start working on that? And then you would go off and do it. And you own more of it at that point, right? You're expected to, you're not just writing something to fit in. You're actually building something new. You have to still work within the constraints of the same project, but that's, but it's, you have more ownership over it, right? It's more driven by you. Back-end development. Between those two, I mean, if you really want to, so again, I mean, when people say back-end development, they mean a lot of different things. So if you want to like learn how to write web backends, and by that, I'm using the traditional terminology where the front end is the code that runs in the browser, the back end is the code that runs on a server. So CS 240 is a course that, has been floating around the department and people have been handing off to each other. Wade's teaching it this semester and I've been peeking at what he's doing. And I think that I think the stuff he's teaching is great. And I think there's a lot of it's stuff that I recognize because it's the way that I do things, right? Whether it's, now I don't like Python, so I don't use Python, but whatever. But, learning how to build RESTful API endpoints, learning how to deploy stuff using containers and things like that. So I think there's quite a few concepts in that class that would be super useful if you want to do sort of backend stuff. Yeah. So I would probably, again, it's not, the thing to keep in mind is that 240 does not replace 233 and 241 in the sense that there are later courses that you will not be able to take if you take 240, like sort of hardcore systems and networking stuff. So so just make the choice with that in mind, right? In the sense that, so for example, if web dev is something that you're excited about, which I would encourage you to be because it's awesome and it's probably the most powerful way to deploy things today. If you're interested in that, I mean, we do have a course on web development. I think it used to be a 498, but I think it's going to have a new number now. But anyways, it's out there. It's being taught by one of our faculty members, Ranjitha, I think. And so that class would be a great one to take. And then you just have to make sure that 240 is going to meet the prereqs for that course. I don't know what they are. I would be surprised if that course had 241 as a prerequisite, mainly because the kind of deep systems work that 233 and 241 are going to prepare you to do don't really mix in with web dev that much. I mean, on some level, programming is programming, and like writing malloc will help you become a better programmer, and then you'll be able to use that skill to do something else. But I don't know. It's a sort of a different set of challenges, different ways of thinking about things. One of the challenges with web dev is always that you have a network in between these two parts, right? So you're really, on some level, building a small distributed system. The idea that like the back end is throwing content at the front end is just pasting it onto the display is very, very old fashioned. And so at this point, what's running in the browser is frequently what's running in the browser is actually much more complicated. So if you look at the CS125 website, the totality of all the code that's running in the browser is actually much more complex than any individual backend service. Well, one or two exceptions, right? But a lot of the backend services that we use, we try to keep very simple, whereas the client kind of encompasses everything. And so I would argue the client is actually the more complex piece of software at this point. So anyway, all to say that, if it's an option, if it works out for your degree program, and if you're not going to miss out on courses you might want to take by taking 240, it looks like a great class. And I think, again, I give Wade a lot of credit for teaching some really useful stuff in there, right? Like, I didn't, the course was supposed to do cloud computing, but no one ever really knows what that means. But the fact that they are doing, again, work with containers, understanding how to build sort of microservice type things is super cool, right? I mean, that's how we do stuff. Like, that's how people deploy services today. Well, I have a lot of MP. Yeah. I mean, that's, this is a particularly programming courses. I mean, this is a, computer programming is a skill. It doesn't stop being a skill after my class. And you learn it by doing stuff. So every course, I mean, I shouldn't say every course. Many courses in our department have MPs to do. Trying to think. I mean, it's probably easier to list the courses that don't have MPs. 173 does not have programming assignments. 374, as far as I know, does not have programming assignments. There are probably some other, I'm trying to think of required courses that don't have any programming components. People use different names for things, like some courses call stuff labs, and and not everything has something called an MP, but even some of our courses on things like statistics and probability does a lot of programming in Python. The course on numerical methods does a lot of programming in Python, right? A lot of times, even like you want to learn machine learning, you do a lot of programming in Python, right? Or whatever. On some level, as a computer scientist, sometimes programming is our way of exploring the world, right? It's like one of our senses or something, right? It's like you can read a book about how machine learning works and all the theory behind it and stuff like that. but you also do kind of want to do something, right? That's what's cool about it, right? I mean, if these things existed only in some theoretical realm, and if you couldn't see that, for example, you can upload a photo to Google and it knows that there's a cat in it or whatever, right? Speaking of cats, did you hear me talking about you? Or is it the birds that are over there that brought you up here? That's well timed. Anyway, so yeah, I mean, that you want to I don't know. I mean, I guess at least for me, for my kind of person, like making stuff go is really one of the things that's big fun about this. Yeah, I don't know if I agree with that. We don't have too many applied courses. I mean, I think a lot of the stuff that you do in computer science is kind of pretty applied. The question is applied to what? I mean, most programming courses are going to be preparing you to do some type of programming. I think the question is, what type of programming is it, right? And what can you do with that? So for example, you take 240, you're going to learn C, you're going to learn P threads and all this stuff. Does that stuff get used a lot? Like, I learned that stuff back in the day, and I could probably still use it if I needed to. Do I ever use it now? No. Just because of the type of work that I'm doing, right? So it's like maybe if you went on to be a Linux kernel developer or something like that, you would use some of that stuff. But most of us aren't going to do that, right? And so it's just different parts of the tech stack, right? And I do agree. I mean, I think a simpler way to put it would be simply that we don't do very much web dev, right? We don't do the web stack, right? We do a little bit of the back end pieces here and there. We do very little of the front end anywhere. I mean, I guess this 400 level course is one of the only places I've heard where people are really doing anything with that. We only got a few minutes left, so I'm not going to go on some major rant here, but my personal opinion is that a lot of this has to do with academic discomfort over JavaScript. I mean, if you're programming on the front end, you're probably going to use JavaScript, and I do know why. I know why, but I don't agree with it. There's a lot of academics that just, it's like you say the word JavaScript and you can see them throwing up in their mouth a little bit, or like they make the sign of the, it's that language, and this is not just true in academia. You can go on Hacker News. It's a lot of flame wars over JavaScript. I mean, it's a very polarizing language. Modern JavaScript is incredibly cool. It's an incredibly powerful and incredibly elegant, very interesting language. The old stuff that you find floating around, it's still out there, is awful, right? And I think, and unfortunately, like, language trajectories matter, right? I mean, there are some languages that came out of the box with a lot of good design thought behind them. JavaScript didn't. Like, it was, I mean, the origin story behind JavaScript is it was thrown together in like 2 weeks to ship with one of the early versions of the Mozilla web browser, right? So it's literally developed, in the amount of time that we're giving you to do one of these MP checkpoints, like somebody wrote a language. Is it good? Is the really old JavaScript? Well, no. And what do you expect, right? I mean, the person that whipped it together is like a pretty talented programmer, but still, like 2 weeks is not enough time to design a new language. On the other hand, if you look at so again, it's sort of like, looking at the y-intercept versus the slope, right? The y-intercept for a language like Java was much higher. I mean, Oracle spent years developing that language. They hired the best people in the field, or some of them, right? People that had worked on other programming languages and had relevant experience and who were deeply enmeshed in like some of the ideas surrounding that, and were, and they had time to think about it, right? And to sort of like Go is, I think, in sort of some ways the same way. Like, you got together some really smart people and you gave them enough time to do a good job, right? And so the y-intercept of a language like Java was much higher. But you also have to look at the slope, because it's 30 years later now, maybe 30, maybe 40. I can never remember. I mean, Java and JavaScript, in addition to the weird link between their names, which has nothing, I mean, the two languages have nothing to do with each other. I think I was in graduate school before I really realized that. My whole undergraduate career, I was like, oh, it's like the scripting version of Java or something like that. The two languages have no relationship whatsoever, except for the fact that their names are very similar and they were released within like months of each other. the same year. So, but again, you don't you look at the slope. And again, I would argue with someone who enjoys working with JavaScript, and particularly with TypeScript, which is sort of a modern twist on it, that as a language, it has evolved and improved rapidly. And I would argue probably those lines between Java and JavaScript crossed maybe a decade ago, maybe more recently, just because Java's just sort of been slow to evolve. So, but I think, there's a lot of people out there in the tech industry who, see the old stuff and have memories of that and are like, and have not, they probably haven't tried to use JavaScript for a long time. It also doesn't help that JavaScript currently, and this is going to change, right, within your technology lifetimes, but JavaScript has a monopoly position within the browser. It's the only language that runs inside, every web browser. There are efforts to change this, and people, I think, are desperate to get around this because, again, there's a lot of hatred and FUD about JavaScript that floats around in the technology space. And so I think that's the other thing about it. People don't like being forced to do something. And so that has not helped the language as well. But anyway, all to say, we don't teach JavaScript. I'm not aware of a major university that teaches JavaScript in any serious way. I'm sure there is one, because there's so many universities, there's always a counterexample to anything like this. But if you look at the languages that are used throughout most computer science curriculums, Java, very common. Python, incredibly common. C++, more common than you would like. C, never going away, right? Those are probably the big four. Then you get into like the Lispy stuff. So I shouldn't leave out Lisp, Scheme. That family Racket is kind of a new variant on that. Those get used as well. That's what happens when you let like a mathematician take over an intro programming class. They want to use something like really strictly functional, which I think you can learn well on a lot of these different languages, but nobody does anything with JavaScript anywhere. And it's kind of sad because again, it's a cool language and it is the way to do things on the web. So. Anyway, yeah. Well, no. I mean, that's connected. Yeah, like Ben points out with the web dev, right? Which is that people that go through, and then I don't know how. I don't know. Don't fall into this trap. I mean, there are people in this program that pick up somehow, despite the fact they've never really used it, this like weird irrational hatred for JavaScript. I remember someone was so proud of the fact that they had taken, I think, one of Wade's projects and they had converted it to not use any JavaScript, and I was like, why? It just sort of, I don't know. People are weird. So anyway, like JavaScript, I don't know why this is. It's always, again, I mean, if you forced me to go back in time and write JavaScript, when it came out, oh man, I mean, it's awful. But the new stuff is good, and particularly TypeScript, which is a version of JavaScript that allows you to add types to it, is really slick and just a really cool piece of technology and fun to work with. So. All right, I'm over. I'm over time, so I'll stop here, and I will. I think tomorrow tomorrow's lesson is a little on the shorter side, and it's the day before break. So I think what I'll probably do is maybe I'll do some office hours this afternoon, and then we'll just take tomorrow off. But I'll let you know. So I probably won't see you tomorrow, except on the lesson. But I hope you guys have a great break, and I'll see you when we get back.